Okay, this is just a quick intro to RapidMiner by way of a few steps in their tutorial that comes as part of the application itself. So let's go to tutorials, and that brings this up, and you go to this tab here, or if it's not already there, and it gets started. And let's check this out. So this is retrieving data and then checking out the data. They call it operators and processes. So I guess we can say that at the same time that we retrieve data, we learn a little bit about what's meant by operators and processes. So I'll just not save any changes. So you get this. So they say we have a super brief intro to using RapidMiner on the left of your screen. So let's check it out. So that's over here. Maybe I'll make it a little bit bigger. RapidMiner Studio has a lot of features to offer. In the next few minutes, you'll learn how to use RapidMiner Studio to perform basic data science techniques such as accessing data, transforming it, and building a model. And down here in the explanation, they say notice the dotted line preview in the process panel. So this is what they call the process panel. I guess this is what we call the repository. This means like where you access your data. And these are operators. This is what things that you want to do to the data. And over here they have something called parameters and help. And here is they say, notice the dotted line preview in the process panel. So they're talking about this dotted line here. So this is what we're going to build in this particular part of the tutorial. This shows you the process that you will be building in that tutorial. Okay, let's click here next. So let's start by retrieving some data about the Titanic passengers. Find the repository panel on the left of the screen, so that's here. Open the folders samples and then data. Drag the Titanic training data set and drop it into the process panel in the middle of the screen. So they say go to the local repository, find the repository, open the samples. So let me close the local one actually and go to samples, and then data, and drag the Titanic training data set and drop it in this so-called process panel. So let's find it. Titanic training. So we'll learn the difference between what we mean by training and so on. But anyway, let's just bring that here. Oh, let's see what happens. If you just put your mouse over it, you get a kind of display of what's actually in it. So I guess we could go and sort of scroll through it. And here. So this is like what's in the data set. Anyway, let's drag it like they said and put it here. Okay, so they say, good job, you have just added your first operator. So they call this like an operator. So operator basically means something that will do something, right? An operator does something. So we've got an operator. They call it the retrieve operator. And since it's called retrieve, we can take that as a hint that it's probably getting something or retrieving something. And it's probably going to retrieve the Titanic data. So in this case, it retrieves data from the repository. Now let's see what you can do with it. So let's click next. Okay, so click next. And so they say connect the output port. So we don't know exactly what that means. The output port of this thing with the result port on the right side of the process panel. So here's the process panel. Here's the right side. So this is the result port. So what they want us to do is connect this to here. So they say make the connection by either by dragging a line between the ports. So let's try that. So drag a line. I just clicked on that left one, and I'm going to drag it over to here. And then when it responds, I can let it go. And so it gives me this picture. So basically what we're telling RapidMiner is that somehow we want to take our data and then look at it. So maybe instead we might have had a bunch of processes in between, but no, we're just saying we want to look at it now. Now I think I can put the mouse over it and just delete that and try it the other way. They say the other way is first click on one port and then on the other. So let's try that. Click on here. Well, I guess it's the same thing. And then there. Okay. So they call this some kind of process. So they say, excellent. So what does all these terminology mean? I guess they when they want to divide up all the steps in a, when you have a data mining task, you have to do a bunch of things. So they call each step maybe a process. So they said, excellent, you have built your first process in RapidMiner Studio. You can now look at the output of the retrieve operator. So we have this so-called retrieve operator. It's not really clear what that means, but anyway, we have it, and we can look at the output because we dragged it over to here, which means we can see what comes out of it over here probably. They say whenever you want to see the output of an operator, make sure it's connected to the res port. Okay, here. And the res port is the result port. Now, I don't know why they have to use res. It's only 3 extra letters just to write out result, which would make it sort of easier to understand. For some reason, they thought they have to simplify it to res. Okay, but anyway, it's the result port. Let's click next. Okay, so now they say we can see the results of this by clicking the Run button. So that's up here. So I'll click it. Okay. So all this did was show us what was in the data. So all of that was just to show that what was in the data. But this is just kind of getting used to this interface. I mean, we could have just opened up, for example, Microsoft Excel, and we would have seen something like this. So kind of simpler. But anyway, this is different than Microsoft Excel, and we're just getting used to it. So now we can see that this is like Microsoft Excel data file or spreadsheet, and we have a bunch of columns. So we have the age of the passengers. Each row here is a passenger. And we have, did they survive in the Titanic or not? And what's their gender? And how many brothers or sisters? How many parents were with them? And what's this thing here? Passenger, what is that? No, I can't see it. I don't know. I can't see it. Okay, so something about passenger. So they say, nice, you have run your first process in RapidMiner Studio. When you click the Run operators, when you click Run, the operators in your process will perform their actions. RapidMiner executes the process and shows that there's not much of a process involved in that last thing, but anyway, and shows the data connected to the result port. So it shows whatever you connected to that result port. The center of the results view, in the center of the results view, you can see our raw data about the Titanic. So this is the center, about the Titanic passengers, such as family, size, age. On the Statistics tab, we get a statistics summary, which provides useful information. For example, how many survived, and for example, suppose you want to know the average age here. Well, if this was Excel, you could do that pretty easily. Usually there's like a button up at the top here in Excel, and you can just get the average. Or you want to get the count of males and females. That takes a little more work in Excel. Let's try doing what they said, which is clicking this thing. They said the statistics tab. So here's the statistics tab. Okay, so the sex here, these are the counts. There were 320 female and that many male. The average age, no, not the average age, it's the minimum age and the maximum age. What else? Can we do anything else here? I guess we get a picture of it like that, which is nice. And we could click on open visualization. Let's just try that. It's a pretty good chart. So anyway, that one good thing about RapidMiner is it does give you very good charts. Okay, now how do I close this? Probably here. No. Okay, I closed too much. So let me go back. Now, if you want to go back, you didn't notice that we were in the results pane, but you can go back to here, and that shows you this process pane. So going back here is the results. Going back here is the process. Let's try that again. Let's run it again. Okay, so we have the same thing again. If we click on statistics, we can see age like that, survive like that. I guess we don't get the average age automatically. I'm sure there's a way to do it. Let's click this and see what happens here. Okay. Okay. So let's go back to design. And we're back here. Okay, and let's go to the next step. Congratulations, halfway there. Well done, you've just mastered your first tutorial. To quickly review, what did we do? Operators perform individual actions. You can connect operators together to build a process. So we'll see that we can do many operators in here. To see the output of an operator, when you see the output of this, you connect it here. Running the process performs all the operators and automatically shows the results. Okay, let's go on to the next tutorial. Okay, let's do some data science. In the last tutorial, we loaded a data set and ran a process. We found out that this many passengers survived. Actually, I didn't check that, but let's build a process to see if those survivors have something in common or not. So a little bit of data science here, trying to figure out if there's anything about the people that, and they're trying to understand the data and see if there's anything that these people who survived have in common. Okay, let's click next. Drag the Titanic training data from samples. We're going to do the same thing again. Drag this onto here, anywhere. You've defined the first operation of your process. Now we learn how easy it is to build a machine learning model on this data. Okay. So we're going to study in our class about decision trees, but we're going to use one here. Decision trees are a popular statistical modeling technique that finds hidden patterns in the data. Let's build one. Find the operators on the left. Okay, here. Open the folder called Modeling Predictive. Where is that? I guess it's here. It doesn't say Modeling Predictive, but Modeling, Predictive, and finally Trees. Okay, so let's try that. Modeling, Predictive, and Trees. Okay. Drag the decision tree operator and drop it after the retrieve Titanic training. Let's move that over. Decision tree, not decision stump. Here's decision tree. Which one? Oh, sorry, here's one. And drag that here. Okay. Now you don't have to put it there, but it makes it easier if you do that, I guess. Certainly makes it visually easier. Okay. Good, now we have the operator in the process, but we still need to connect so this is the idea. You take one of these and connect it to another one. So basically it means we're going to do something here and then basically take the output of that and do something with it here. So you still need to connect the two operators and define what we want to see as output before we can run it. Okay, let's try that. Decision tree operator will build a decision tree, whatever that means, for us based on our Titanic training data. We still need to connect these operators together to build a process. So a process is a bunch of steps. So we have some steps here, but we're not really finished because we have to connect them. Connect the output port here. I don't know why they can't say output, but they don't. Okay, connect the output port of retrieved Titanic training here with the input port TRA for training. Really awful if you ask me, but okay, I would call it training, but TRA for training of decision tree. So decision tree has, this has a certain set of ports over here. You can see that these have different set of ports, and this on this side has a port that this one doesn't have. So different operators are doing different things, so they need to accept different things and then output different things. So each type, this has one particular set of things that it's going to output and input. This doesn't necessarily have the same. Okay, so anyway, connect the first output. Did I skip something? Connect the output port here with the input port. Okay, so I'll click here and then here, and then I guess I did it. Connect the first output mod, which probably means model, of the decision tree with the result port. We already saw the result port over here, with the result port on the right side of the process panel. Okay, and then press the run button. Okay, so I guess mod might mean model. So anyway, they want us to connect this with that. Okay, so now we went like that. So now we're doing two things, whereas before we only did one thing. Okay, and then press the run button now, and it's going to run this whole process. Okay, and now we get this so-called decision tree. And let's see if we can move things around a little bit. And how do we make this a little bit easier to see? I guess we do this. And that. And that. Can we drag it? Yep. So it's a little hard to see the whole thing so far. But let's see if we can do it. Okay, well, it looks a little hard to see the whole thing. But anyway, okay. Great job. Your process should now be complete and deliver a decision tree. So this whole thing is called a decision tree, which explains to you what most of survivors and most of victims had in common. Read more explanation on operator, ports, and decision trees. Let's click on decision trees and see what that does. Okay, so he's going to talk about decision trees. So, okay, let's not read that right now, or listen to that right now. Okay, but let's just look at one thing. So, you can see this tree here. It's called a tree. And this here is called the top of the tree, or the root of the tree maybe, or the top node of the tree. Anyway, I can see that this tree was built with the top node, or the root, or the top of the tree, with sex there. Now, remember what was sex in our data set? It was one of the variables. if I click back here, no, I don't see it. But if you remember, it was one of the variables. What were some of the other variables? I think there was age and some other things. So generally, in a tree, when you have things extending from one of these, it means that this is a variable. So here you can see age has some stuff coming out of it. That means age should be a variable. And like here, number of siblings, that was also a variable, so it can have stuff coming out of it. So that's the way a tree works. Anyway, this tree happened to put sex at the top. So how do we read this? The way we read it is that sex, remember, of course, can be female or male. Maybe I should make it bigger for a minute. So this says that if the person was a female, then check how many number of parents or children on board, and if it's, what's that say, less than 45, no, 4.5 maybe, or no, I don't know what this says, but anyway, we just follow it down. Okay, let's skip that. I can't read it very well, so I'm not going to go through it right now. Let's click next. Great, you have just built your first machine learning model. This was not hard, was it? You know how to load data. You know how to load data. We did that. We loaded the data, the Titanic data. Add a machine learning model. We did that. That was the tree, decision tree, to the process and execute both steps. From our resulting decision tree, we can see clearly, I can't see anything clearly, but that survival was not coincidental at all. In fact, it tells us that as a female passenger with a small family, you were really lucky, at least if you were holding an expensive ticket. Well, we'd have to go through all of this to see that, so I wouldn't say that we can clearly see anything yet, but I guess if you study it carefully, you could clearly see it. These tutorials have only shown you the tip of the iceberg of what you can do with RapidMiner. To keep learning and become a RapidMiner master, click the link below to start the next tutorial. Okay, let's try a little more. Now, if we go back to I guess we're starting our third chapter of the tutorials. I think we went through maybe 2 chapters already. Well, let's click this and view all. This one is called importing data. Okay, let's click here, view all. Okay, here was all. So we did this one and this one, I think. I'm not sure actually, but I think so. Importing data, so that's probably here, number 3 maybe. Okay, anyway, let's do a little bit more here. Getting your data into RapidMiner is often the first task. So we're not going to be using RapidMiner. You can use RapidMiner, but you have to learn it on your own because we're not going to cover it. It does give us really good graphs, and that will be helpful and useful to you. You can also use other ways to get graphs like Tableau. You can also use Python, R, and so on. And Weka also gives you some graphs, just they don't look as fancy as these. But anyway, the first thing you need to do is, and maybe in some way you won't believe this, but maybe the hardest thing of all is getting the data into whatever you're doing. So is getting it into Python, getting it into R, getting it into Weka, getting it into RapidMiner. It seems like, oh, that's so easy, right? You just have an Excel file and you just bring it in. Well, first of all, you don't always have just a nice Excel file. And second of all, sometimes the data won't fit in, won't go smoothly in, like it'll have weird characters in it, or it'll have weird commas in certain places, or if you have text in the data, that's can often confuse the whatever you're using, whether it's Weka or this or whatever else. Sometimes that will confuse it if it's text in the data. And sometimes even more complicated is when you have multiple files that contain your data, and they might have different variables, and then you have to sort of figure out how to put it all together. That's a fairly complicated process, actually. Hopefully we won't encounter that. And anyway, so getting the data into the system can be difficult. Like when I first started doing this, I was working with Twitter data, text data, and it was really hard to get it into the system, and I spent so much time on that process. So anyway, getting it, if it's just numeric data, it's probably going to be easy. But anyway, don't think that that's going to be an easy step in the process. It could be the hardest step. Now here they're going to give us something that's not going to be hard. But in practical settings, it could be hard. Okay, anyway, getting your data into RapidMiner is often the first task you will need to complete, your analysis. In this tutorial, you will learn how to import files into the central storage of RapidMiner, called the repository. So the central storage of RapidMiner is called the repository. So, you bring your data into RapidMiner and it's accessed in this panel. We will continue to use data describing the Titanic accident, but this time it will be imported from an Excel file. Okay, so it's like we have an external file that we have on our desktop, or maybe it's available on the internet, and we want, or maybe even in a database, and we want to connect to that database, or we just want to, anyway. But here we're going to have it on maybe on our desktop. Okay, we'll now go through the most important steps of building analytical processes, starting with data import. In later tutorials, we will cover data preparation. So data preparation is like cleaning up your data and other things like that. And modeling. Modeling is like the fun part and the interesting part, but many times, if you're using a system like this, it's the easiest part. We will also discuss some of the steps you saw so far in more detail. Okay, so download this Excel file to your computer. So where is that? I guess there's some file on the internet that we're going to download. So let's try that. So RapidMiner Titanic, and you download it. Okay, so now that's like an external file that we have on our computer, not in the repository yet. To import the downloaded data into RapidMiner, click the plus import data in the repository panel. Okay, let's do that. And follow the steps in the wizard. Okay, this is called the wizard. So where is your data? Oh, I think it's on the database. No, that's not where it is. It's here. It's in my computer. So, if you're working in a company, it's probably going to be in a database, and you're going to connect, maybe click this. I don't know what will happen. Let's see what happens. Select the location. Okay. Anyway, we're not going to do it that way, but you might have to do it that way. So anyway, click the plus again in my computer, and documents. No, I think it was probably in, have to go up, or maybe go to here, and whatever, users, and go to, now I'm lost. I'll go up again, users, whatever, where is it? Probably, okay, let's try this one. And do I have downloads? Well, you can search for yours. Okay, I found mine here. You have to find yours. Okay, now it's loading it, and it looks like this data set has more stuff in it than the one we used before. So it has number of siblings. This passenger fare. That was passenger fare. You can see that. Cabin, first class, or whatever. Port of where you left, lifeboats, and so on. Okay. Maybe this is lifeboat number or something like that. If you got on a lifeboat, if you were lucky enough to get on a lifeboat. Okay, let's continue. It says next here, down here at the bottom. And format your columns. I guess we just keep going. And it says no problems here. So that's what you hope to see, but that may not be what you see. And you know, this is all made up nicely for us, this data set, but you probably, or you may not see this with your own data. And then maybe finish. Okay. And now maybe it's finished. So they say store it in your local repository, so that's what we did. Okay, the repository panel in the upper left, blah, blah, blah. Okay, so we did that. This will simplify. You should always import data into the repository, especially when it comes from files like Excel or CSV. This will simplify the design of analytical processes a lot, since RapidMiner's repository stores describing metadata together with the data. So I guess the alternative would be not to put it into the repository, and that might be something you would need to do if the data set was really large. So it might not fit in RapidMiner. I don't know, maybe RapidMiner can hold any size data, but I doubt it. Now remember, we're back here in the results, but we could go back to design, or we could go to results. Now design, we haven't actually done anything but import the data yet. But anyway, it's in there, here, now. Okay, let's go to next. Okay, click the design tab to return to the process panel. So we did that here. Okay, when you drag data from the repository into, or drag the imported Titanic data from the repository panel into the process panel. Okay, let's do that. So here it is. We'll drag it in. Okay, some kind of symbol there. I'm not sure what that is. When you drag data, it transforms into a data loading operator. Data is not actually loaded or delivered until you run a process. So what is that thing? Potential problem detected. Parameter repository entry accesses a repository by name. This may not be portable when share. Okay, I'm not sure what this means, but I'm not sure. Got it. Okay, let's go to next. Create a connection to review the results. So we've done that before. Connect the output port here with the result port over here. Make the connection either by dragging a line or whatever. So let's do that. Click here and click here. Okay. Only data which is delivered to one of the results ports here on the right can be seen after the execution of the process. If your process does not have at least one connection to a result port, you won't see any results. It doesn't mean nothing happened, but you won't see it when you execute it. Okay, next. Press the Run button. Once you run, you switch to the Results panel, which is up here. Remember, those are operator outputs you connected with one of the results ports on the right-hand side. Anytime, click the Design tab to return to the process panel. Okay, so let's click Run. Okay, so I guess we did it. And now we can see in the results panel what it looks like. Okay, and then let's go to next. You've just imported your first data set. From now on, each tutorial includes some additional questions to further improve your skills. Take a look at the challenges below. Challenge: So now they're going to ask us to look at the data, just looking at it here, and can we see anything? Can you find out how missing values are shown? So do we see anything? Not really. Look around, keep looking. I don't see any so-called missing values. How about if we go over this way? Here. So these are probably missing values. So how are they, what did they say? How are they shown? They're shown with a question mark. So many times if you're running a model, it won't work if you have missing data. So this could be a problem. But it depends how RapidMiner chooses to do things. And then we can go back and check the statistics tab. Let's try that. Okay, so we have all of this stuff. And what do we have? We have, let's look at age. So it says the type is real. The missing are 263 are missing. And it's minimum age, maximum age, average age. I don't know why. Maybe we had this before also, average before. And what else? Age, like type, and I don't know. Anyway, okay, so the one thing a little bit of a mystery is this type. What is this? So age is a number, so they call it real. And number of siblings is also a number, but they call it integer. Because age, you can be, 22.1 years old, but you can't have 2.3 siblings. So that's an integer type, and so on. Now, I don't know what polynomial means. This may be their own designation for something. Okay, anyway, next, the statistics tab. How many people did travel in first class? So where is that? Passenger class. Doesn't say right there, does it? No. Or maybe second, third. Okay, let's click here. So we can see first class here. I don't know, how do we see that? Can't see it, and I don't see it here. Second, first, 323, I guess. Is that about right? Maybe, yeah. 323. Okay, so we can see that kind of thing. So that's part of analysis, right? You might, you can answer questions just by doing what we've done so far. Let's go back down. Play around with some of the charts if you like. Okay, let's try that. Okay, so this is called a scatter plot. Now, whenever you look at a chart, no matter where it is, I recommend, at least this is what I discovered for me, is that I'll just get confused when I look at a chart. So I have to look at the axes first. So I see here's an axis. I don't even know what it means though. It's not very clear, is it? This one is number of parents or children on board. What is this? What is this axis? I don't even know what it is. X-axis. Well, that will really make it confusing if you don't know what the axis is. Let's try a different axis. Let's try age. Okay, now we have age. Maybe it was age before, but so now we have 0. Hopefully nobody was 0 years old. And then the oldest age is 80. Now, what is this number? Let's not use that. That's confusing. Let's use something else. Let's look at age versus okay, let's look at this. So age versus number of siblings. So you can see that when people were in this age, each dot, I guess, is a person. So you have a person that was 20 and its x coordinate was 0. I'm sorry, its y coordinate was 0. The y axis here is the number of siblings. So somebody who's 20 and 0 means their age, their x value is 20, and their y value is 0, means they have 0 siblings. Whereas someone here, their age is 20, but they had one sibling. And here, their age was 20, they had two siblings, 3 siblings, and so on. So that's what this is. And what is yes, no? That's this one. Okay, so we can choose the color to be something. In this case, that we chose the color to be, did they survive or not? So here we have blue is, yes, they did survive. Oh, look at that. When you put that over there, you can see they're actually a lot more blue than we see because the nose are covering it. There's actually a lot more blues than we think. And then here, no. It's a little hard to work with this because, a little hard to work with this in the sense that it's hard to see everything at once because some things are covering up other things. Some people are covering up other people. But anyway, is there anything we can gather from this? So this is no. These are people that didn't survive versus people that did. I don't see anything particularly. I can't see any pattern in terms of the number of siblings or the age. Is there a difference? People that did survive, didn't survive. Maybe there were more no's in the older people. Because when I go here, I can see that some of the people are up at 70 and so on. But when I go here, there don't seem to be as many people. There's one person that's 80 that did survive. But other than that, there are less older people. Maybe we could say that. Anyway, you could do some analysis by looking at this, by looking at these graphs. And, here. So one problem we have is seeing, the greens cover the blues, it looks like. So one thing you can do is you can just slide this over. What it does is just sort of move these points just a little bit at random. So it kind of unhides stuff. So let's try that. We add some jitter. So it's not, that's just being used just so we can see it a little bit better. Let's do a little bit more. It still doesn't really show that well, but how about a lot? Yeah, it's still hard to see. I can't see where the blue and the green are without doing this. Anyway, that's what jitter does. And Weka also has this jitter. Now you can change the type of graph. This is called a scatter plot, where you have like dots like this. But you could do all these other kinds of plots. What's a heat map give us? I don't want to read that. But maybe for other variables, this is number of siblings. But what's this? Number of siblings. Number of siblings on board. And what's this thing here? This axis. I'm not sure. How about if we change it to something else? Age. What's that going to do? Nothing. Well, you can play with this maybe. So for some application, some data, that could be interesting, and for some it won't be. And we could do box plot. So this is for number of siblings. So this says that the most number of siblings were 8. So some people had 8 siblings. But most of the data is in here, is what this says. Now, if we look at a different variable, let's look at age. That that didn't work. Value of columns. I think I need to do this. Click here and take this one out. Now let's try it. Okay, so that's better. So now we can see the age. This line here stands for the median. So the median age was about 28 or something like that. And then this is an age where 25% of the people were below here and 75% were above here. And this is 75% were below here and 25 were above. So those are called the lower quartile, this age. The lower quartile, actually, when I put it on there, I can see is 21 years old, and the upper quartile is 39. Well, we didn't study that, but hopefully you would have studied that in a statistics class. Anyway, these are just graphs, and there are lots of them. You can see there's many different graphs we could do, and choose many different types. Okay, let's go back to the statistics and the data and the design. Okay, so what's the next tutorial? Is find out the highest fare paid by women. So how would you do that in Excel? Let's go back to this, well, we lost it now. No, here, results are here. So what was that? Find out the highest fare paid by women. So how would you do that in Excel? You could do filtering in Excel. So you could filter out only females. And maybe you could then sort that according to that data, sort the results of the filtered data by the fare. Where's the fare? Here. So you would sort it by this, and then you could find the highest. So that's one way to do it. So in other words, I'll just do that quickly. So I opened up the data in Excel, and then I'll select all of it, and I can do filter data and filter, and that gives you these little arrows here. And then we want to get sex, and then choose only female. Okay, so these are all only females. Now, I don't know if we can do a sort here or not. Let's try it. I want to sort on passenger fare. So I'll go to data and sort. Maybe it will work, maybe it won't. Passenger fare here. And let's sort from largest to smallest. So did that work? Yeah, we still only have females here, so it worked. So I can answer the question. It was 512. And so you could do that in Excel, but that is, I could answer this question here, find out the highest fare paid by women, but they're going to do it some other way here. Okay, so I'll stop with this. You can continue to learn this, and there's a lot of other videos on the RapidMiner site, so you can do that. And my caveat is, okay, so RapidMiner is fun, it's pretty, and Weka is also good, very good, and we are going to learn through Weka, but you can easily transfer your knowledge from Weka to RapidMiner, or you can switch back and forth. But our lectures are going to be based on Weka. We're going to use Weka to illustrate the concepts of our lectures. Okay, so that's all for now.